For the record, I did go buy the hat with Bitcoin, honest money and all this. So now where's one of these little clicker things? There you go. As for how many drinks I'd had when I bought this thing, who the heck knows? But yeah, so I wanted to. All right, well, slides get up eventually. I wanted to really go talk about dishonest devs, and I'll go and start kind of saying, well, what do we mean by dishonesty? And another way to put it is, well, what do we mean by trust? And apparently the likes of the CIA and the NSA, they go to define trust in a lovely way, which is the thing that can go break you. The thing that you go trust is the thing that can compromise you. And equally, when you go talk about developers being dishonest, they're being not trustworthy and probably in a position to go and break your stuff. Well, why does this matter? Because when you go trust someone, like our slides here, they can go break your presentation. And all this decentralized stuff we work with, it's supposed to be about removing trust, but we are interacting with it through software. And that's a big problem. But if I'm going to go talk about security, I always like to start with, well, what are we trying to prevent? And this isn't like normal software where, you're letting things happen. You're trying to go prevent something bad from happening. And, being an Australian, this doesn't exactly make me terribly happy, which is Australia's passed a law about, a year and a half ago, which essentially allows the authorities to go up to any developer and just say, hey, we want you to go put a backdoor in something. Oh, and by the way, you really can't go tell anyone about this. In fact, you can't even really tell your boss. Heck, in the early drafts of the law, you couldn't even tell your lawyer, which does get to an interesting sort of meta-exploit of, well, what if I claim I was told to do this and couldn't verify it, but I was actually working with someone who, say exploited this bug I added. It's a big issue, and we need robust systems to go catch this kind of stuff. Also, being finance, well, you get issues like this, and I'm not really expecting you to read it, but essentially it's a Bitcoin talk post talking about how one of these many, many little altcoins apparently added what looks to be a backdoor to their code where you could remotely, over IRC, get your node running this coin to do anything it wanted. It was straight up backdoor. Bit clever how they went and hid it, but the real issue here is, of course, you're running an exchange, maybe an exchange with 50 different coins like this. How are you going to audit each one, and how are you going to prevent this kind of remote backdoor from, say, taking over your infrastructure? There's a lot of things you do to mitigate these risks, but these are fundamental risks. And I think you kind of sum it up as, well, does our software do what we want it to do? But more importantly, does our software not do what we don't want it to do? And I've given this talk once before, so I think I finally pronounced the last bit right. But it's a bit of a mouthful, and I think it really shows how difficult this security question is. You're trying to rule things out, and ruling things out is hard. Let's go back to my first example. Let's suppose you have a copy of Adobe Photoshop. How do you know that it does what you wanted it to do? Well, you go look at it and see if it did what you want to do. I want to go put a funny face on someone else's body. Cut and paste, done. It's pretty easy to verify it did what I wanted it to do. It's much harder with security stuff because you kind of got to rule things out. And this is sort of like the famous Simpson one of the tiger, the rock that keeps tigers away. I have some rock. I claim it keeps tigers away. How do you go verify it actually does that? But it's sort of worse in a way too, because we live in a world where maybe this anti-tiger rock was actually created by the pro-tiger faction, and the pro-tiger faction is sticking a microphone and a GPS tracker inside and trying to go and upload that information to the pro-tiger faction to get the tigers after you. That's the kind of level that we're really talking about here. And it's a tough auditing question. And we can even do this in practice. Let's go look at this wonderful little gift bag from a last conference I was at. Well, a USB condom thing. It's supposed to prevent communication. So we actually have a well-defined question. Does it prevent one USB device from talking to another? which really comes to the question, should I plug this into my computer? Because if it doesn't do that, if it does something else, I mean, it could go and start telling my computer to, act as though it's a keyboard, type in some commands. Well, we can audit it. I got a heavy glass and hit it till the case broke, and then just held it up to the light. And I used to be an electronics designer, so I know USB has 4 wires. 2 of them are for signal, 2 of them for power. Well, that looks like 2 wires going from one side to the other, and 2 wires not. And I'm pretty sure I remembered the 2 signal wires being in the middle. So I can go audit right there. Does this thing do what I want it to do? Now, it's got a bunch of other stuff around, but I'm pretty sure that goes to the case, so I think that's okay. Maybe there's something clever going on. Maybe someone hid some traces underneath parts I can't see. But I've done a reasonably good job of auditing what happened. And in this case, I decided after auditing it, I'm happy to plug that into my computer. I think it does what it's supposed to do. And with this in mind, what can we kind of go say to this? We can audit things. We can go talk about, our findings. So, does this guy have a point? Is your full node really a full node? Did you personally go audit it? Well, there's an interesting difference, though, between this hardware thing. I've actually got one sitting here. There you go. I audited this, and I could go and tell you guys whether or not my device was clean, but you may have one sitting in your pocket, and of course it's not necessarily the same device. I kind of told you how to audit, but I haven't really described to you, is your actual device a clean device? Does my audit cover your audit? Well, the beauty of software is in the right mechanisms we can do this. And this is why I would call our role as auditors to be whistleblowers. Provided we live in a world where we can verify that you're installing the same software as me, and I also go and audit the software, I'm really acting as a whistleblower. Every time I find an issue, I'm blowing the whistle, letting everyone know. And this is why I think this sort of sentiment is actually quite dangerous and sort of very misleading. Because you're kind of saying, well, trust is okay because you can, you always got to go trust someone. But it's a tangible difference between trust where you have to independently audit everything and trust where you're just hoping that at least one person does. And we have things like certificate transparency and so on to make sure that you're looking at the same code as me. So in theory, I would argue this kind of sentiment is wrong. And we have good ways of auditing. Now, though, I think the question is, well, let's go into the practice. What actually happens when we try to go audit software? What's the mechanics of code review? And I came up with this little example. Let's suppose I'm on my dev Rust VM, and I create a little initial commit, and it's called the all your base project. It secures your base, and I run a little command, and base secured. Pretty simple code there, right? And I go and push it up to GitHub like everyone does, because we all love centralized stuff. And now, let's suppose we get some decent guy, we'll call him Mr. Good Guy, because Alice and Bob are taken, and he goes and downloads the project, runs it, and thinks, oh, it's all one good, but does it actually work? Well, of course, if you look at the code, you might notice something, which is in Rust, if you just type, command new, that's actually something called a builder pattern, where you're setting up a bunch of options. You haven't actually run the code. So if you want to actually run the code, you got to go and ask it to go output the thing, which means, give me the output of the command and so on. So, submits a pull request and all that. there's your patch. Go fix the issue. No big deal. Commit it, and now we'll actually run the command. And if you're not a Unix guy, basically chmod is makes everything can't be executed, can't be read, can't be written to. As we all know, the best security is to take your computer and encase it in concrete and dump it at the bottom of the ocean. And let's suppose we go and fix this. So I might want to scroll up a little on this one. There we go. So, now scroll up. There. All right, so let's suppose this guy goes through the whole git pull request thing, and finally I come back and say I've merged it. And remember, you're in his perspective. What do you do next? You do git pull. That looks all well and good. We got one more change. Maybe I added a remeet or something, and checked added some more code. Well, let's see what actually changed. Run git log. There you go. The change is in there. Merge remote tracking branch. It all looks and good. Well, what actually happened there? I mean, what actually changed? Because funny enough, when you run through all this with my repo, that's your new code. Looks a little different than what git log showed, doesn't it? And run a few sudos, make everything world readable, writable, execute. Not quite what you expected. So I really want to go ask, what went wrong with all this? I said all this great stuff about code review, but where did this example go fail? Is this the code maybe is a little silly. What's actually going on under the hood there is plausible. And I've seen things kind of like this. The initial backdoor I showed way up at the top, the clever thing they did was similar to this kind of trickery where you go hide some not so innocuous code, some innocuous code. Well, first of all, the very beginning here, where we are, there. The very root cause here is actually a Rust thing, and Rust has the ability to go tell you, did you create something and not use it? Very often in code, creating something and not using it is a sign of something going wrong, and I need to go submit a pull request and go fix this in Rust. Which I think will then get to our first point. You got to choose languages where you can actually audit things. You got to choose languages which actually have kind of rules and type checking and so on. And as an example, I maintain a library, Bitcoin library, Python Bitcoin lib. Python is really bad about preventing one piece of code from interacting with another piece of code at a distance. On the more technical side of this, essentially, it doesn't enforce writability. Like if I have a piece of code that has a reference to some object, I can go write it in 5 different places. And that leads to problems. And this is the kind of big picture thing where you got to say, well, if we want to rule out these kinds of things, we need to make it easier to audit. And we also have, of course, the problem where Git itself isn't designed with auditing in mind. The guys behind Git aren't really security people. I mean, Linus famously chose SHA-1, which even back in 2004 or 2005, whenever Git started, we knew it was broken. Now we've actually shown breaks in SHA-1, and with maybe $50,000, $100,000, whatever the estimates are these days, I could have also done this attack by creating a SHA-1 collision. So, one Git commit actually has 2 different files that could have been the same Git commit. Again, this kind of suggests we should consider moving past Git. But, maybe there's even more fundamental one, which is, well, after I pushed and all, what happened when this guy ran the code? Notice how he got the code, then ran it, and then investigated what it did. Cargo run is basically downloading dependencies and running the code. Well, what environment does it run the code in? It runs the code in the same environment you're looking at it. Right there, we broke our root of trust. We had a trusted environment which we expect to have, for instance, a text editor that will actually show us what we're supposed to be looking at. But the moment we run code within that environment from an untrusted source, all bets are off. And unfortunately, this is just standard. I mean, most programmers do this day in, day out. Be honest, like, I'm not very good at not doing this. I happen to go use CubesOS, which is essentially a collection of virtual machines, and you can at least, with CubesOS, easily say separate, your email from your Rust development. And in my case, I separate my Rust development from, say, my open timestamps development and my Python Bitcoin lib development. But I'm still guilty myself of, looking at patches and running patches in environments that really shouldn't be. And we need tooling to do things like, when I type cargo run, a separate virtual machine should be fired up and run all this untrusted code in it. We're just not there yet. You also got to ask the question, again, going back to this auditing, how do I know what dependencies Cargo downloaded? And Cargo, it has this massive GitHub repo of dependencies and all the SHA-1 hashes of the packages, which itself is much better than most languages do. Python doesn't really have this. But that big Git repo, that's not signed. There's no public commitment to it. There's no mechanism by which I can go say, well, that was definitely the version that compromised me. So again, we're kind of failing there, even though this should be possible. And in the case of certificate transparency, which I mentioned earlier, well, for SSL certificates, when you go to your bank website, we've solved that problem in that there's effectively a blockchain of every single SSL certificate in existence. And your phone goes to that blockchain and verifies, is that certificate there? And if it's not there, not publicly visible, it won't accept it. But we haven't gotten that for software. We're just nowhere near there. And that does need to change. I even have a personal experience with this, with the Zcash trusted setup. I was one of the, I think it was six people who did the initial trusted setup. And when I say trusted setup, well, what happened there is Zcash's privacy protections sort of force a private key to be generated. And that private key can be used to counterfeit Zcash money. Now, the 6 people, they collaboratively generate that key. And in theory, or at least the marketing material, is that, well, if any one of them are honest and actually delete their part of the key, no one else can reconstruct it, et cetera, Zcash is secure. Well, let's look at this word honest. Remember when I talked about dishonest versus honest and trusted and untrusted? From your perspective, in the Zcash trusted setup, I'm not an honest person. Because I can't say whether or not the software I ran was actually doing what I thought it did. My personal honesty is actually irrelevant to you. What's relevant to you is my actual real-world honesty. How does my interaction with trusted setup affect you? And for that, I'm dishonest. Because what software did we run? Well, we all ran this pre-made CD that itself was created by sources that no one can really audit. It's just not feasible to manually go through hundreds of megabytes of assembly code and figure out where the back door is. And it's assembly code because, well, yes, the code that directly went onto the CD was compiled in a deterministic way where you can also recreate that process. The code that compiled it wasn't. And that code that compiled that was created just prior to the Zcash trusted setup. So you have opportunity to go backdoor something. You have the inability of auditing, inability of whistleblowing, essentially. And because of that, I can't say from your point of view, I'm trusted. I can't say what I did. All I know is I ran some software and who the heck knows what it did. It's not a good situation to be in. And also go talk about the issue of attribution. And where are we? Yeah. So if something like this does happen, well, who's to blame? Now this repo, which is an actual repo you can find on GitHub, it's the most recent thing I've uploaded, it's not signed. So my name might be on the Git commit that has this sneaky trick of hiding stuff in a merge commit, but who actually did that? Well, there we are. So that's a standard Git push. And it says right at the top line, the authenticity of the host, github.com, can't be established, key fingerprint is whatever. Do you want to continue? Well, I could claim to you guys that, oh no, it must be a man-in-the-middle attack. Some guy was wiretapping my internet connection, and they pretended to be GitHub, and SSH doesn't have any mechanism of authentication other than just trust the first key you see. They call this trust on first use. So from that first moment, how do I know that I actually uploaded to GitHub? I could tell you guys that no, it wasn't. I didn't upload to GitHub. It was some man-in-the-middle attacker. And now we don't have attribution. Now there's no consequences for me backdooring your computer. And unfortunately, the reality is a lot of projects don't sign Git commits. They have no attribution. They have no way of you verifying what you're actually downloading. Bitcoin Core is half decent with this. There is a script and a set of keys that are allowed to merge commits in Bitcoin Core, but how many people actually go and use a script? How many people use it consistently? Probably not that many, and I've tried using it, and the reality is there's not enough tooling around Git to actually plug in and, for instance, prevent downloading a commit, or merging a commit that isn't signed. The tooling just isn't there. And I'll say I think the risk here too is really one of what regulations are coming down the line. Like it or not, security is important. There are real costs when this stuff gets broken, and if you incur enough real costs in the real world, someone's going to take notice and decide to go stop that happening. We might end up in a world where there's regulations about who's allowed to go code. If we continue to screw this stuff up and make these things happen enough. And chances are any regulations but who's allowed to code are not going to be done in a way which is sane. They're going to be done in a way where what matters is what college degree you went to. So really, I'll kind of end with a bit of a call to action and say, I think that in general, the software industry needs to just fix these issues. We need to stop being complacent about this type of security. We need to stop, asking for perfectionism too. We see PGP and it doesn't quite work, but it actually signs code. The answer shouldn't be, well, let's go ditch PGP because of these unrelated issues. The answer should be, well, let's figure out how we can go fix this. And some of these answers will kind of be annoying. There'll be things like, if you want to be part of the open source community, you need to go sign your code. You need to have, you need to participate in this. Yes, it's inconvenient, but it has to be done. And with that, thank you.